Hello everyone. Let's wait some time for people to gather and we'll start lesson 4. Let me post on Discord as well. Whatever I post on Twitter, I just copy paste Twitter. Let's wait for people to gather. Okay. Examples. All right. Still waiting for people. Hello, Mikhail Fox. I wonder, will we have more people? Let's wait some more. Okay. Right. Oh, come on. Give me the full link. Slides and the code. Lesson. Chapter 2, lesson, the ultimate expression. Okay. Right, and paste it there. All right. Let's see, did I miss anything? Hello, Cat Girl. Hello, VKS, Dan. Let's wait a few more minutes and we'll start. 11 views now, it's okay. So before I start, I'll talk about what is going on. So first, after this, we will have a 1 week break before we start C# chapter, which is completely everything about C#, all the nice features that we are not using at the moment. So it will be very useful. We'll go into professional C#, like all that you need to know about C# really. So it's gonna be very focused just on the language. So that's nice. And also at the end of the lesson, I'll try to announce a little document that I'd like you guys to fill so that we can start forming groups based on schedule and interests of different people, and skill, of course. So schedule, interest, and skill. Skill not so much, it's something that I will be evaluating, but interests and time zones is what matters. Okay, I think we can start now. So So today's lesson is about interface, and we'll talk about why interface is so useful. Why is it basically one of the most commonly used things to reference? And when should you use it? When should you not use it? And why should you use it more often than not? So we'll talk about interface, about the fourth pillar being abstraction. We'll compare interface to abstract class, and I'll try to give you some recommendations of when to use it and when to not. So we'll start from an example. Imagine that you have to program a game where pretty much everything can fight everything. For example, we have humans and people. So you have Pokemons and people. So Pokemons can attack and defend. Humans, people can attack and defend. Other than attacking and defending, they have nothing in common. And but they have those two features, being able to attack and being able to defend in common. So they're both attackers and defenders. And to summarize this, they're both combatants. They can do combat between one another. So we have an interface for a defender. Just don't try to understand what this is. Just look at the essence of it. Does it make sense? So a defender can get hit points. A defender can defend from attack, and a defender has a position. So, you defend yourself, and when you defend yourself, you get damaged, or not damaged at all, but it affects your hit points. So we need to know how much hit points you have. And of course, if attack doesn't reach, well, it doesn't hit you. So we also need to know your position. And that's defender. An attacker attacks a defender. Anything that is a defender, an attacker can attack. I think this makes sense, right? So let's continue. This is just simple stuff, human common sense expressed in code. Don't mind the interface keyword yet. And then a summary of both is that combatant is someone that can be targeted and attack. So it is both a defender and attacker. And we have our two combatants, a human and a Pokemon. And therefore, we don't need to know if we're fighting between Pokemons or humans, or Pokemons and humans, we can just say that combatant 1 fights combatant 2, or in a more specified case, that it can be a gladiator and a Snorlax combating each other. So you can see gladiator hits Snorlax and Snorlax hits back. And apparently Snorlax just won. So what is an interface? Now the main question should be answered. An interface is a contract which basically defines what a class can do. So if I have an interface, iWeapon, that means a weapon can attack. So it can produce an attack. Let's say I generate a random attack which has stats such as range and attack and damage. So get an attack is what weapon can do. And thus it has no body. It only has method definitions. And it doesn't even have access modifiers within methods, because whatever access modifier interface has, its methods must have that too. Because a class that implements interface must have also those methods as public. Because something that needs to be implemented needs to be public, and therefore there's no point of having access modifier explicitly for the interface methods. And if you try to write it, it won't compile. And therefore, interface is the most lightweight abstraction that you should be using as much as you can if you want to achieve loosely coupled code. And I say as much as you can, and I mean roughly 70% of all the references that you'll have, all that your class refers to, will be something that is an interface. So another interesting thing about an interface is that a class can do many things, and therefore it can implement many interfaces. And in fact, it's a good thing to implement many interfaces, many small interfaces, rather than one big interface. It's good because for an interface, you really don't want it to change, because it's a contract. If contract breaks, you don't want to break it, because then it will cause problems for the ones that implemented the contract. So anyways, interface can be implemented, multiple interfaces can be implemented by a single class. Here's the semantics. You need an interface keyword. Again, access modifier can be, might not be, up to you. And methods without body, without access modifier. And by convention, we call type names that are interfaces using I something. So I attack, I person, I email, I reader, I writer, I whatever. So I something is always the interface name, always. In 99% of cases, and 1% of cases being just people not being educated. It's not a great convention, I would agree, but it is a convention nevertheless. So if you see something that starts with an I, it's an interface. And how do we implement an interface? Well, imagine if you had an interface for an attack. And attack can get damage and can get range. Those are the two basically defining properties of an attack. So we have two attack implementations. A punch, which always has 1 for range and 60 for damage, like static, hard-coded values that don't really change. And a spit, something that depends on varying factors and therefore is affected by randomization. So when I do a spit, I give it a power between 0 and 1, and the base spit values will be modified by that spit power. So for example, if I get damage, my spit can be from 0 to 10, or if I get range for that spit, it can also return something in between 0 and 20. So that's spit for you. When you implement an interface, it's important to know that an interface itself is a virtual method, but the implementation is not. So if you could overload abstract class methods or virtual methods after the implementation or after first override, you cannot do the same with an interface. So interface therefore makes it so much more convenient to have abstractions that are final upon being implemented. And that's what makes it so nice and cool. You have code that is solid, that doesn't really change, but the change can come from an outside, from another implementation if needed, but it doesn't affect something that is already implemented. And that is really attractive for an interface. That makes code solid, strong. And do you have any questions? Is everything clear? Is the use of interface roughly clear? Let's move on. So interface is the best abstraction. And what is abstraction? Before that, I'll answer the question of Catgirl Aurora. So if parent class A uses interface I and has a child class B, does class B also have the interface? And the answer is yes, it does. So what is abstraction? And actually, the definition is varying, and me myself had a different definition for abstraction. For most of my career, I thought that abstraction was just a unification of all other pillars. But abstraction is actually what I called encapsulation. Abstraction is hiding of details, hiding of unnecessary details. And this is done through various things, which we'll talk about soon. So the misconception I had before is that encapsulation is details hiding and grouping of the related members like functions and data, but actually it's not hiding data, it's just grouping data. That's encapsulation. And abstraction is just hiding what you don't need to know. And abstraction is so great and so useful and so revered in OP because it turns complex code into simple concepts, into something that a human can understand. So let's compare interface to other types and see the similarities. So normal class must have methods with a body. There is no abstraction, really. Abstraction exists there through private and public access modifiers, but that is as little as abstraction can get. For abstract class, we have abstract methods. That's the abstraction. Also private methods. So abstract and private. Now we have two ways of abstracting something. And with interface, everything is an abstraction because it doesn't have any implementation details. It's just a contract. So to compare an interface to an abstract class, well, you could say that if an interface and an abstract class had if an interface and a class had a baby, it would be an abstract class. Because I always think to myself that abstract class is half an interface, half a class. It's neither, really, because it can have some implementation and some abstraction. And if you look at what is the highest level of abstraction, and that is interface. Class is absolutely only details. Abstract class might be some details, some implementation, and interface is just absolutely abstraction. Therefore, if you have an abstract class without any implementation, reconsider your life choices and refactor that to an interface, because it's not an abstract class, it's an interface by definition. So I like summarizing object-oriented programming as just 3 pillars, and the fourth one being a combination of the other 3. And what I mean is that encapsulation is abstraction because we hide private members and group-related things under a single class. Inheritance is abstractions because we generalize things, so we hide the details of a specific child by just using a parent. And polymorphism is abstraction because we don't need to know child implementation in order to use it as a generalized parent. Therefore, abstraction is just a combination of the other 3 pillars, but it is so important that it is a thing of its own, and it's that important. A little sidetrack, but encapsulation is called differently in different sources, defined differently. Sometimes it is mentioned that is included with access modifiers. Sometimes it's mentioned only that it is grouping of related things, members under a single class. But abstraction is always something called that is hiding details. And those details are either data, functions, or implementation, or all 3, of course. And that hiding is achieved through different things: access modifiers and abstraction structures like interface. And here's some recommendations for an interface, for abstractions really. So don't use abstractions just for code reuse. It should be logical. It should be something that makes sense and isn't just for the sake of reusing code. For example, a team is not a list of players, even though you just think you want to add and remove players to it. It is not a list of players. It has a list of players. And therefore, when you design stuff, try to keep it consistent and keep it stable. Don't violate the contract that you defined. When you make an interface and that interface has 1 or 2 methods, keep them and do everything in your power to keep the contract untouched. Because if you do start changing your contract, the implementations must adapt to that contract. So just like in real life, after you sign papers, nobody changes those papers. It's really a violation against the law. The same law applies to programming. It's just not very nice to change something that we agreed upon, which is being the contract, the interface. And this especially applies to big projects, especially projects where you work in teams or multiple teams. If one team changes a contract and now they need to notify the whole team, other teams, that the contract changed, and it doesn't end there. Every piece of code that implemented that contract now needs to adapt, now needs to make changes, and it just ripples horribly. And therefore, change in contract and interface is just something that should be a taboo. You shouldn't do it. Only in the most early stages of your application it is kind of allowed, but even then you should really think well if the contract that you wrote is good or not. Now, some things that is not strictly that you shouldn't do, but you should avoid those things. So avoid virtual methods. If you can, don't do them. They make sense when you want to add extra implementation to the child or have default implementation of a parent across the children. But it's really usually not the best way to do. And why is that? Because it makes the method unstable. There's nothing that prevents someone of overriding the implementation and throwing an exception, like not implemented exception. And thus it just provokes and suggests not the cleanest implementations in our code base. So avoid virtual methods. Also avoid big interfaces. And avoid big interfaces for the reason that the bigger it is, the more likely it is that you won't be needing all that it offers. So we don't want to violate the contract, and therefore we don't want to have big responsibilities. We want the contract to be as small as possible, and therefore interfaces should not be big. They should be small. We should combine them. And changing the contract, right. So for the first one, I said that you should not violate the contract. And violating the contract means a different thing than changing it. I actually talked about changing the contract. Violation of contract means something that if you expect a duck to quack, when you call a method quack, you should see that it quacks. But if I call a super robo duck method quack, and it suddenly throws an exception, and it always throws an exception, that is a violation of a contract. Don't do that. Don't just override the method and make it do nothing. Don't just override the method and make it throw an exception. That is against the coding principles, and you shouldn't do that. It is a hard no to something. And changing contract is almost as severe, but it does happen, so avoid that. It happens, but please avoid it. And it's possible that you might always use the same dependency all the time and that you need to hard code it, and by hard coding dependency I mean creating it, not inject it, but prefer to depend on an interface and inject it. And there's a whole bunch of patterns that unlock if you inject dependencies and not hard code them. And a summary of this is pretty much to make interfaces small, make combinations of them, and when you depend on something, when you inject something, inject not a concrete class, but it's an abstraction. Inject not a class, but an interface. That is the recommendation. And that's it. So now please write down one thing that you think you understood very well. So just write a sentence that you understood very well, like basically your own summary of this lesson. Something about anything, about an interface, about an abstraction, about the 4 pillars of OP. Just write one sentence about what you think understood very well. And also please write one sentence that you would like to understand better. Something maybe was clear to you, but you would like to know it even better. So please write that. About inheritance, yes, interface can have inheritance, and that's perfectly fine. And in fact, I did demonstrate you that. You see here in this slide, we have two interfaces, defender and attacker. And our combatant is someone who can defend and attack. So a combatant inherits those two interfaces. And this is a prime example of interface inheritance, which in fact supports multiple. But yes, guys, please write one sentence that you think you understood very well and that you would like to understand better, and we can proceed with that. That helps for me to double checking if what I explained was clear. And right, someone asked, Okie dokie Choki asked, what do you mean by injection? So what do I mean by injection? I'll just open Notepad, I guess. So injection would mean something like, imagine you have a class, and this class is called let's see. Let's say we have a gladiator, the same gladiator, right? And we say that a gladiator has a weapon. So he has a weapon. And maybe a sword. Maybe a weapon is not a great example. Well, okay, whatever. A sword, for example. So this is injection. When you pass something through a constructor or a method, it's called an injection. When you pass a dependency. So a gladiator has a weapon. Oops. So a gladiator has a weapon. And if I set the weapon for constructor, something that is not primitive type, it is called injection. But this is a specific dependency. It means that all gladiators have only swords. So I don't want to depend on something specific. I want to depend on an abstraction. So if I have weapon interface, I should depend on a weapon interface and not a specific weapon type. That's what I mean by injecting interface. Here I injected interface. I can inject a weapon. Imagine that there is a weapon that implements weapon interface, but maybe I don't want that. Maybe there is something, maybe a weapon is something so vague and abstract that there is no point of making a separate class for it. Maybe there is no weapon class. There's only something that implements each weapon class, and each weapon class is so unique that I don't have a base weapon. So an interface is a better choice here. I can inject it. I can inject this weapon, which can become any other weapon. What I don't really want is to have something like this. I don't want for a gladiator to have a sword only. Even though all gladiators have swords, always, I don't want this situation to be hard-coded. I want options. I want to be able to inject a different weapon. What if something changes? So I don't want to hard-code my dependencies. I want to be able to inject them like this. Now let's move to Visual Studio, and there is kind of a complex example of what I showed. So first, about the structure of the project. We have 3 folders called Combat, Examples, and Utilities. Utilities is just some helper class. Examples is a simulation, like a demo. And Combat is where all the action happens. So in Combat folder, we have armor, attacks, combatants, and weapons. So we have an armor interface, which basically is a multiplier between 0 and 1. And for example, we have chainmail. So chainmail is basically means that it reduces damage by half. So we have just interface, armor, and implementation, chainmail. The funny and interesting thing about this implementation without using armor class and instead using an interface is that this has 0 memory consumption other than creating an object, because the value 0.5 is not stored in memory. It's just returned when it's needed. It's not stored in the chainmail class, it's just returned as a constant. So we have armor, we have attacks like a punch. A punch hits hard but has short range. A slash has 20 damage, so it hits way less but has slightly bigger range. And a spit is an attack that is randomized. So a spit, like we saw before, is an attack that hits between 0 and 10 damage and has a range of 20. Actually, I'll make it 50. I think it makes sense for 50. It's too weak if it's just that. And range to be 20 is fine. So we have our combatants next. So we have those 2 interfaces for attacker, who can attack only something that defends and who has a position, and defender, who has hit points, defends from attack, and has position. And the summary of both, which is a combatant, which can defend and attack. And we have 2 implementations. A human, a gladiator, who has hit points, who has a weapon, who has armor, and who has position. All the things that is needed for the interface. And so when I create a human, I pass him hit points, I inject a weapon and armor, and I set a position, initial position that a human will have. A human defends from an attack. So what does it mean for a human to defend from an attack? A human has a vest of armor on top of him. So his armor negates a certain amount of damage. So whatever armor value I get is going to be subtracted, multiplied actually, from whatever damage is left. So all damage is 1, and after I subtract the armor is the damage that is left to be done. So my hit points are equal to the damage I get from an attack multiplied from the negated damage that comes from the armor. So that's the defense of human. And get position is trivial, nothing interesting. And attacking is getting attack from a weapon that a person has. So a weapon provides some attack, and I check if I am in range of the one that I want to attack. And if I'm in range, then I attack the one that I want to attack, and that thing defends from the attack. And Aurora said, something I just thought up. Interface inheritance makes something more general, like iCombatant is more general than iWeapon, but class inheritance makes something more specific, like Sword might inherit from Sword, but is still more specific. I would say that the degree of generalization remains the same. I mean, interface is an abstraction, and no matter how many times you inherit something, it's still an abstraction. So iWeapon was an abstraction, iCombatant was an abstraction, iAttacker was an abstraction. Everything is still an abstraction, just an abstraction of a different thing. And for inheritance, indeed, when you have a class that implements something or inherits something, it is something more specific. But an abstraction is still an abstraction in all cases. So we have a human, and he does those things, and we have a Pokemon who is also a combatant. And basically, when we create a Pokemon, we give it HP. It has a set of attacks and position. So the difference from human implementation is that it has attacks that he can choose from, no weapon, and a random factor. It also has no armor, so when you hit the Pokemon, you just take damage away. And when you attack a defender with a Pokemon, you randomize the attack. There's no weapon to get the attack from, therefore you randomize the attack from the attacks that you have. And you pick a random one. And again, if the attack is in range, you do the attack. So that's the implementation of those two interfaces. And there are some interesting things about this, very interesting actually. So imagine if we had traps. Imagine if combatants had traps. What is a trap? Can anyone say what is a trap? What interface should a trap implement? What is it? A trap is an attacker. I would agree. So when you step on a trap, because, I mean, you need to have a position. And when someone steps on a trap, well, you do damage. And let's say, yeah, let's say we have a trap class where we inject an attack. So we inject an attack. So when someone steps in a trap, we attack that person with the attack of a trap. and a position is a position. So the attack and position of a trap do not change, because, you know, a trap is a construct. So when you create it, it doesn't change. So this is quite neat, isn't it? So I have a trap that is something general. Maybe I don't want general traps. Maybe I want something. Oh, yes. Position. Maybe I want to have a bunch of specific traps, like to specify what each trap has. So I can. I can make, let's say, punch trap, which is a trap and I need to implement it. So I just set a position, but a punch trap will do a punch for an attack. So really neat, clean, small class, which is my trap. Let's say I want to have a blade spike trap, blade trap. So again, I will implement a trap, which is something that will always be a slash attack. And let's say I have a spit trap, which is also a trap. And something very super simple that, again, I inherit. And the attack will always be a spit. So imagine if you had a grid, and each grid had I guess something that it can interact with. So if you step on a trap, it attacks you. That's the logic. Well, you can simulate it. Now, how should I demo it? Okay, this one for the end. Examples: dueling simulator, trap simulator. So so let's say we have a class called dummy, which is a defender. Doesn't do really anything. You can attack it infinitely, but it has a position that changes. Yeah, a position that changes. And hit points, always the same. You cannot really destroy it. So get position. Get position. So let's create a dummy. So we have a point which is returned in here, which is set in here. I meant position, I meant position, I meant position. Okay. So when we create a dummy, we set a point, its location, its location can change as well. So public void set point position. So we pass a point, which is a position, which is a new position. So let's create a dummy, which is at point 0, 1. And I'll make this method better. Move to position. Position is not read-only. Okay. So we have a trap as well. So actually we have a whole bunch of traps. So traps. So what kind of traps do we have? We have a blade trap, which is at position 0, 0. We have a punch trap, which is at position 0, 2. And we have another trap called a spit trap, which is at position 0, 4. So we have a whole bunch of traps at our disposal. And Warren, poor dummy, is about to get its ass handed to him. Okay. Position point. Okay. Great. So now let's simulate dummies movement. Step carefully to a position. Maybe let's have dummy destructibles. So dummy defend from attack, hit points, right? Float, hit points. Get hit points, return hit points. So attack, get damage. Yeah. Get damage. So okay. Trap simulator. Step carefully. So we have a dummy that we move. Yeah, dummy, sure. That we move through a field of traps. And we move it to a position. So we say, hey dummy, go to position, and we, for each traps, and if dummy get position is the same as traps position, we say dummy defend from trap attack. No. We say trap attack dummy. Yeah, they do. They do, and that's very good. We should just say trap attack. And we say if defender position is more we have a distance, var distance, so we say if distance from defender position to my own position, so if distance is less than attack range, then we attack a defender. That's the logic, right? So when the poor dummy steps through the field, it gets continuously attacked by the traps, and if a trap is in range of a dummy, it's done for. It gets attacked. So let's better to have a position that is outside the traps, and let's mix them a bit. So that we don't accidentally make this a mess. So we have a dummy and traps. And we want to keep on stepping while the dummy is still alive, and report the HP of dummy. And we want to move to a random position, to a position between a, let's say, 0 and a 0 and 40, I guess. Let's see the traps again. Spit. Spit has a range of 20, from 0 to 20. It varies. And others, punch has a range of 1, and blade has probably a range of 5, makes more sense. Okay, so we have a randomizer, and our maximum is what's our maximum that we can step? 41. Let's say 50. Okay, 100. Okay, 100. Sure, 100. So 100. So var x that we step to is to 100. and y that we step to is also to 100. So we step to a random place which is defined by two random points that we pass to step carefully function. And of course, it would make more sense to step one step at a time, but I don't want to introduce a new thing that you don't know yet, so I won't do that. So let's just randomly put from the top with our god finger the dummy. And of course, this can be var. So it moves randomly, it steps carefully, and let's report report status. So when we report status, we pass a dummy and we say where it stepped. And this means yeah, it will be this bit. Actually, it's interesting what trap will be hit as well, right? Can we do that? Yeah, we can in here. So, okay. This is fine, whatever. So if okay, so let's write, oops. Trap. Okay. And private static void report damage report trap. So so the trap okay, well, okay, trap and here we pass, oh no. Here we pass report trap. Well, we don't know if it hit. Damn it. Okay, we know if it hit actually. Var initial HP. So dummy get hit points. Was hit means that initial dummy get hit points is less than initial HP. And if it was hit, then we report trap, which was the trap, which was this. And get type dot name probably. Name. Perfect. And here let's make this more pretty. So let's do console write. bunch of times. Oops. Trap. Got triggered. Great. And space, and let's set the color, let's say red. Let's say the color will be blue, better. Got triggered. What do you mean? Space is missing. Yes, thanks. And so we have this in red. This in red. And after we're done, we reset. Okay, and we do the same for dummy status report. So we say dummy is fine. So we just say dummy has dummy dot hit points. Yeah, that's fine. I don't want even the point. I want the point in the other place. Dummy. Okay. I want it to be here. No. I want the point to be here. And position. Yes, okay. Okay. HP. So we report the status. So what happens? We created a dummy. We created a bunch of traps. And we keep on stepping. Let's extract this and call this step to your death. This can be a part of this. This is not needed. And let's So trap simulator program run. Let's run. Nothing happened. Why nothing happened? So we step dummy HP. Does dummy have any hit points? Or is it always 0? Yeah, but it should always have 100. Okay. So let's see our trap simulation. So it was going happily. Oh, something happened. Spit. Spit. And again, spit to death. Okay. Let's make this more interesting. Let's reduce the spit. Spit is not this long, and slash will be 5, and punch will be 3. And spit is 10. And let's reduce the distance that the dummy can move through. So, and let's make some more traps. Actually, spit is fine, but I'll make other traps. 20 was fine, but I'll make other traps. So, make your bets. I'll make some punch traps. At 0.20, at 5.15. Yeah. More centered. 10.20. 20.30. Yeah, this is good. Some blade traps. At the corners, let's say. So 0, 100, 100, and at the center. Yeah. Okay, what will kill the dummy this time? Your bets? What will be the last thing that will kill it? Would you guys like to make your bets? Blade trap. There are 4 blade traps with distance 5, which hits 20. There are 4 punch traps with range 3, which hits 60. And then there is a spit trap, which is random between 0 and 50 and 0 and 20. Let's see. So punch trap, you all lost. And let's see the thing is that hit it this time. So spit trap. Spit trap. Spit trap and the punch trap. Okay, let's give it more HP. Let's reduce the distance to a, let's say, 50. So int fifty and some other places. +1. Yeah. Let's run. So punch trap. Interesting. Let's give more HP to the dummy. 1,000. Blade trap. Punch trap. Spit trap. Punch trap. Blade trap. Punch trap. Spit trap. Punch trap. Yeah, roughly even now. It died. Okay, so this is the abstraction. We can create a Pokemon which will step through this field. So I can also create a Pokemon or a human. Let's say it's a Hercules with this much HP. It has no weapon and no armor. Well, I have to create some armor. Damn it. Well, chainmail, let's say. And position. Let's see. Human. It was defender. So now we're talking about a human here. It's not a dummy. It can only defend. Okay. And therefore I said do not hard code things because you'll regret it. If you can make it, if you can refer abstract, you should refer abstract. Oh, but the human cannot move. I think defender doesn't have to move. Defender doesn't have to move. So what do we need? We need another interface. And void move to position point. Position. Great. So now I can make dummy to derive from movable. I can do the same to combatant. I think it makes sense if combatant can move as well. Interface parameters having a name. Just readability, really. No particular reason. Let's go to combatants and let's go to a combatant. So every combatant can also move now. So now I need to implement that in a human. It's very simple, trivial. Adjust position to be set to position. And the same for a Pokemon. Just position to be set to position. And defender. So tough. I passed the defender, but it's not a defender. It's a dummy. A dummy is not a combatant. Dummy cannot attack, so it cannot be a combatant either. How do I work around this issue? Well, quite easily, I would say. Well, no. Defender, combatant, dummy. Okay. Okay, that's good. That's a good idea. I pray. Whoops. So prey is something that moves and defends. And a combatant is both a prey and an attacker. Okay, great. And dummy is a prey. Whoa. And now we will be working with preys. Fixed. Thanks for a tip. So Hercules is stepping through traps, and Hercules is not somebody to mess with. And therefore, it still takes too long, I think. Why is there a blade trap out of range? It doesn't make sense. Okay. Times 2. Times 2. Let's just make this scalable. Times 5. Times 2. Times 10. Times 4. 0. Times 2. Times 4. Times 2. Let's say, and let's reduce this to 20. Yeah. Much more triggers. And the most popular one now is punch trap, it seems. No longer spit trap. But yeah, a cool little game, and you can see that it doesn't matter if I'm a human or a dummy or a Pokemon. Let's create a Pokemon too. Actually, okay, let's create a Pokemon too. Yeah, which is probably fine. In games, you also get hit by several traps simultaneously. For example, spikes and arrows are flying at you, so it probably makes sense, right? New Pokemon 1000. It doesn't need attacks, and it starts at position 0, 0. So if I walk through a Pokemon, you can see that it also can do the same thing. So why is it no reference exception? Oh, because I must pass it attacks, that's the logic. That's the logic inside the Pokemon class. There was no reference exception because it's checking. You see, for length not to be 0. Let's create a new attack. Let's call it slash. Let's run. And done. So you can see that we're able to navigate through the traps with a dummy. And the dummy is just prey, with a Pokemon, which is a combatant, which does combat with its own attacks, and with a human who uses a weapon to do attacks. A completely 3 different classes, but something that, we can interact with. And identically, we can have something that are destructibles. So we can have a bunch of destructibles, like, let's say a wall. So what is a wall? It's a defender. And as a defender, it knows how to soak a punch, and it has a position, and it has hit points. So it really makes sense, right? But I won't continue implementing this. This is exactly like the other one, just from a different part. And now the final example, the more complex example, about interfaces. So I showed you that you can implement multiple interfaces, and multiple interface can derive from other multiple interfaces, can inherit multiple interfaces. But what if, so one last thing that I should show, 2 actually. So imagine if you have an abstract class, super soldier, which is a combatant, but does not implement combatant. What do you think? Is it possible? Is it valid? Will it work? Or must it implement the combatant? Maybe I can write abstract methods to implement the interface later. Will it work? What are your guys' thoughts? And the answer is that abstract class needs implementation. Like, even though it's abstract, you cannot make those methods abstract. They need to be implemented in the abstract class. So abstract class needs implementation of an interface. You cannot work around it by not implementing those. That was my question. Sorry for poorly wording. And, well, last example, which is a as I mentioned, if I have a class super soldier, and I say that I am a human, and human is a combatant, so sure, implement yes please. So I also cannot override the interface methods. As I said, the interface methods are virtual, but the class that implements those methods through its methods, they're no longer virtual, and therefore they cannot be overridden. Now, last example. So we have a combat simulation. You cannot make, well, you can make them virtual, yes. I mean, when you implement an interface, all the details come from the class itself, from the class that implements them. So yes, you can make them virtual if you want to. That is, I mean, after you implement the interface, it works exactly the same as another class. Since it's a contract, it needs to be implemented. Yes, it can do that. Yes, it works. So again, with that super soldier, if human had virtual attack, then super soldier could override that attack. You see, actually a Pokemon had that feature. Some Pokemons, attack twice, so it makes sense for a Pokemon to have that. So I'll actually change it. Void. This is fine, but the Pokemon now will have it. Let's say Hypnotoad. Hypnotoad is a Pokemon. So Hypnotoad is a Pokemon which does hypnosis before the attack. So I just overrid it. And now let's then fight with Hypnotoad versus the Gladiator. So we have our combatants, and this will be Hypnotoad. So we have Pokemon and Gladiator. Not Snorlax, it's Hypnotoad now. Hypnotoad. And name of Hypnotoad. Okay. Also, what if two interfaces collide? Right. And that is a great question. What if they collide? And in fact, in our case, they did collide. So the two parts to that. Let's go back to our combatants. So we had a combatant, which was a prey and an attacker. Prey is immovable and defender. And defender has position. Attacker also has a position. And since they both have the same method, same name, you might think that it will clash and collide, but actually it won't. It takes, if you don't explicitly say which interface you want to implement, it takes the interface, the same implementation will go for both interfaces. So if I go to human, you see human has get position, and it works for both interface implementations, both from prey's perspective and from attacker's perspective. However, I can override this, and I can say prey dot implement explicitly. Right. Basically, this implementation is the same as this implementation. So C# by default understands this as a unified implementation for both. But I can explicitly say which interface I implement, but then I don't need an access modifier. That's also an interesting point. It's a very tricky point. I never do this, to be honest, so I didn't really know exactly the syntax. It's a super rare case. So then you might ask yourself, when will this implementation be called and when will this implementation be called? And the answer is, when you call human as attacker, this implementation will be called, and when you call human as defender, this implementation will be called. But in this case, it's the same. So I hope that clarified it and answered the question. So the final combat. The bets are up, and this time we have two combatants. We have Hypnotoad no, Aurora, you had the same thing that I explained. If it inherits, oh, I see. So you mean if I inherit something that is already there? Sure. So what if prey has attack, move, like void move? Well, you can see again, it depends on the context, and this also works. But I would never do this, because it would then depend on a specific interface that we implement and not what the contract offers. So it's a bit dirty and probably hardly maintainable. Anyways, last demo. So we have a dueling simulator, and we have our combatants. Not Snorlax. We have a Hypnotoad. So we have a Hypnotoad which fights a Gladiator. Hypnotoad versus Gladiator. And they fight until one of them runs out of HP. So they both have, I think, the same HP. Yeah, they both have 100 HP. However, Slash deals 20 damage, but so Sword does a slash with 20 damage. However, Human has Chainmail, which cuts all the damage he takes in half. And Hypnotoad has 100 HP. And Hypnotoad can either do a slash or a punch. And when Hypnotoad punches, it's 60 damage. When he slashes, it's 20 damage. So it's either 20 or 60. And for a sword, it's always 20. But when a Hypnotoad attacks, his damage will be half because human has chainmail. So who will be win given that both are in melee range smashing each other? Let's see. So we have round 0 and let's continue. So Gladiator has 70 HP, Snorlax has 80 HP. Gladiator has 40 HP, Snorlax has 60 HP. Gladiator has 30 HP, Snorlax has 40 HP. And Gladiator has 0 HP and Hypnotoad is the winner. Let's try again. Yes. So both are equal. Gladiator is losing. Hypnotoad won again. Let's try again. Gladiator 70, Hypnotoad 80. Why is it a comma here? Oh, I forgot. Okay. And Hypnotoad 1, Hypnotoad 1, Hypnotoad 1. Actually, it shouldn't be this consistent that Hypnotoad keeps winning. What the hell? Okay, Gladiator won, finally. But that's weird that Hypnotoad keeps winning. Anyways, that's the demo. Let me fix the text somewhere. Not Snorlax. Great. So that's all that I wanted to show today. Let's see the diagram. Beautiful drawing. So you have interfaces D, M, and A. So you have interface IC, which derives from IP and IH. That's fine. And then you have interface D, interface IP, which derives from interface D, and IM, which is also fine. I don't understand the question. Okay, inherits from movable twice through prey and hunter. I movable. I combatant inherits twice from I movable. I don't know. To be honest, I don't know. We can make this, I guess, and see what happens. But I don't know what will happen. I think it will work. It feels like it will work. So I'll move this here. So let's make some wacky interface. Interface IM. Actually, you said, I'll just do what you said. So, defender, movable, attacker, prey, hunter. So I need a hunter. Hunter is something. that a combatant inherits. Okay, let's try it. I hunter is I movable and I attacker. And you're saying that I combatant. So I go back to a combatant class interface. And a combatant is a hunter. Yeah, it works. I think the same logic applies, I guess. Like, if you... So, let's build first before I say nonsense. It builds, so... let's go to a human, I guess. And let's go to the method called move. And explicit implementation. I'm movable. I guess this is fine. It's not really fine. This is bothering me. Yeah, I guess you'll have only one implementation in the end. Even though prey can move and hunter can move, you only have one method that implements it, which is immovable. So it doesn't matter who inherits or when it inherits. It matters what is the source of implementation, which is immovable. So immovable provides the movement. Therefore, interfaces can collide apparently and nothing bad will happen. But that's a great question. Thanks for asking. I would rather not create a separate folder for interfaces because it's a semantic separation and I prefer logical separation per module rather than per semantical part. It makes code cleaner. Though this is a whole discussion around that, and it's more a matter of taste than a hard rule. Now it's time for Kahoot. So let's go. Okay. Let's go. Link. So this is the number. This is the Kahoot link. Let's wait. So loud. Come on guys, only 3 players. Is it really going to be 3 players? All winners, not fair. I'll wait 1 more minute and we'll start. Let's start, I guess. So, what similarities does an interface and an abstract class have? Well done. Let's go on. True or false, can a class implement multiple interfaces? Yes. Let's go on. Is it true that an interface is the best abstraction? The most lightweight abstraction? Yes. Is it true that it's better to depend on an interface rather than its implementation? It is better to depend on interface because you don't have hard dependencies that way. You can swap a dependency when you need it. Therefore, it's considered better. Is inheritance of interfaces supported? Yes, of course. And can one interface inherit multiple other interfaces? Yep. Can a class implement multiple interfaces? Yes. What access modifiers are allowed for interface methods? Okay, so a proof why two people were wrong. So if you go to a hunter interface or a movable better, you see if I write access modifier, like it doesn't even let me. You see, it says the modifier is not valid for interface members declaration. I cannot have an access modifier on an interface because it makes no sense. Because everything that an interface has needs to be exposed publicly so that it can be implemented later on. And thus, basically, whatever access modifier an interface has, the same access modifier needs to be applied to its methods, and therefore it's not needed. Next. Must abstract class implement the interface it derives from? Yes, it must. If you were to design a helper class which formats a string to a very specific format, which construct would you choose? Wow, interesting. The answer is static class because it looks like people were guessing. So we know what it does, and it's a very specific thing. There's no abstraction involved, it's just formatting. You don't need iFormatter in this case because you know that it returns a string. And therefore, static class is better. Normal class is not good because you want something easier to use, accessible, callable from different places, just the formatting. It doesn't need an abstraction. It doesn't need something as complex as a class either. And therefore, static class is the way for that specific case. If you were to implement an emailing system, which constructs would you choose for the email class? An abstract class can have a static method, yes. It's just a class. I mean, normal class can have it. Abstract class is not any different. So you have an emailing system and you send an email. And what would an email be if there is just an implementation of email? No other details, not many emails, just a model class for an email. And the answer is normal class. You don't need an interface. There's no abstraction there. So, might argue, but an email in this case is just something that holds data. Data like text, header, from, to, subject, nothing more. It has no behavior, no logic, just a bunch of data. And there are no multiple implementations of email. The system itself, the email sender, email writer, would be abstractions of some sort, but not the email itself. An abstract class would not make sense if there is a single implementation of email, and in this case it's not set how many of email implementations are there. So yes. But this second guess was a good guess. Each bot has its own pathfinding algorithm. What is the best approach to specify an algorithm of a bot? So if you were to implement some pathfinding algorithm in a bot, where would you do it and how would you link the implementation with the one that uses it? Would you use an abstract class? Would you inject the algorithm through an abstract class? Would you have a default implementation for bots and just override it? Or would you inject an interface through a constructor? And the answer is interface in this case, because a bot is not, it's not bot's responsibility to hold implementation of the algorithm itself, and therefore it makes no sense for a bot to be abstract class, which has abstract pathfinding method, and it doesn't make sense for it to have virtual method for the same reason, because it's not its own responsibility to implement pathfinding. Pathfinding is a thing of its own. It's an algorithm, and that algorithm comes from some other source, and now we have two options. Is it an abstract class or is it an interface? So each algorithm works the same and needs different things, so it cannot be an abstract class because it's too simple and too different to be an abstract class. It just has one method pathfinding, let's say calculate path, and it would return you an array of steps you need to make to reach your destination. And that is just a single algorithm, just one method that you need an abstraction for. And that is a perfect case for an interface. So interface is the right answer because you want to inject some extra behavior to something that natively doesn't need to be aware of how that behavior is done. It just needs to use it. Let's see the winners. All of you are winners, guys. So Resho, 8 out of 12 answers. Barara, 9 out of 12. And Catgirl Aurora, 9 out of 12 answers as well. But the winner. So congratulations. Now about the homework. The homework is in the homework chat. And it's a quite simple one. Yeah, the winner pays for pizza. So the homework is of 2 parts, very simple parts. Part 1, implement the logger. Basically, wow, this sounds annoying. So what the logger needs to do, it needs to log something somewhere when application starts and when it shuts down. And logging can happen either to file or to console. So you need to implement that. And you need to implement both loggers, both to file and both to console. And another thing, part 2, is that you need to take homework, your first homework, and all the console printing statements should be done through a logger. Either of the 2 loggers that you chose, but consistently throughout the whole application. That is your homework. No tests for this homework, so it's more like to just get shit done. And before I end the lesson, do you have any more questions? And if not, I will actually do one more thing. So let's see. Can edit copy link. I won't post on Twitch because it's risky. I'll post to BC discussion, actually in announcements. So group projects, how do we call it? Interest form is here. If you would like to participate in a group project, please fill it in. Thanks. There will be groups made based on the answers. So what my intention is to see people of similar free time gaps and of similar interests. So I give you 3 slots for interests. Number 1 being the most interesting thing that you want to do. Number 2 being less interesting. And number 3 being not so interesting. And based on that, we'll form groups. After you fill your name, I'll try to determine your skill based on your homework. and we'll group people of similar free time and interests, but different skill levels. And I expect at least 2 groups to be made. Is it view only? I don't think so. Maybe. No, you should be able to edit. Is it really not possible to edit? Can you write anything anywhere? Protect only me. Where is the freeze? Format, freeze. Yeah, you can. So, all good. Okay. Preferably put your full Discord name with a hashtag, like your profile thing. So if I click mine, all right. Well, streamer mode enabled, but if you click your user settings, my account, there's a hashtag there. So you just select that, and here you go. You have it. So full Discord name with hashtag, so that people can DM you if they want to. Eventually, I think we'll be making channels per group that will be private to that group, but that mentors will also be able to see. So 1 or a few channels per group. And we'll work from there. So I'll let this sync for around a month or 2, and after that time we can make projects and groups. When we form groups, get to know to each other, understand what time we can afford, and it'll be nice. Discriminator. Okay, didn't know. In free time, it should be time zone. Yeah, it should be time zone and the time itself, the gap of time. So range of time of a given time zone. Ranges of time per day. So every day when you're free, so there's a lot of space there. I'll leave a lot of space. Whoa, whoops, sorry. Okay. Yeah, that's it for this lesson. So thank you guys for your attention, and I'll be going now. Bye bye.